This is Jacob's Algebra, Chapter 13, Lesson 5, solving quadratic equations by taking square roots. So we've learned how to solve quadratic equations by putting the equation in standard form, factoring the left side, and then using the product rule to set each factor equal to 0 and then solving for x. Now we're going to learn how to do this by taking the square root of both sides. So what if we have something like x squared equals 49. Well, we have two ways to do this. The way that we learned in the last section was that we put this in standard form, which would be x squared minus 49 equals 0 because we subtract 49 from both sides. This is in standard form now. The right side is 0. The left side is a polynomial in descending order. And now we factor the left side, which is going to be x plus 7 times x minus 7, because this is a difference of two squares. Say that equals 0. And then we set each factor equal to 0. X plus 7 equals 0, and x minus 7 equals 0. So if x plus 7 equals 0, we can subtract 7 from both sides and get x equals negative 7. And when x minus 7 equals 0, we can add 7 to both sides and get x equals 7. So x equals negative 7 and x equals positive 7, both of those values make this equation true. Now, using the square root method, we're going to start with x squared equals 49. And what we're going to do now is just take the square root of both sides. So the square root of x squared is x. The square root of 49 is going to be a plus or minus 7. And the reason why we need to do this plus or minus is because we had an x squared over here. And when you square a number, it doesn't matter whether your number that you started with was positive or negative, you're going to end up with a positive square. So we don't know whether this x is positive or negative. When we square a positive 7, we're going to get 49. When we square a negative 7, we're also going to get 49. So whenever you take the square root of an x squared, you always have to say that the other side is plus or minus that number. So let's work one that's a little more difficult. What if we have x plus 4 squared equals 9? Okay, so in this case, we have a square on the left side, and we actually have a square on the right side too. We can take the square root of both sides. On the left side, when we take the square root of x plus 4 squared, we get x plus 4. And on the right side, the square root of 9 is 3, and we have to say plus or minus 3 because we don't know if what was inside of these parentheses was a positive 3 or a negative 3. So now we need to get the x by itself. To do that, we need to subtract 4 from both sides. So we get x equals negative 4 plus or minus 3. Now, so there's two different values here for x. So we need to figure out what is negative 4 plus 3 and what is negative 4 minus 3. Well, negative 4 plus 3 is negative 1. Negative 4 minus 3 is negative 7. So x is going to equal negative 1 and x can equal negative 7. Both of those values will make this equation true. Okay, let's start looking at some problems from this lesson. The first one we're going to look at is problem number 4. Problem number 4 says express the square roots of the following numbers either as integers or in simple radical form. So we're going to look at part B, which says 30. What is the square root of 30? Well, if you look at 30 and we break it down into its factors, 30 is 2 times 3 times 5, and those are all prime numbers. We can't actually break the 30 down at all, so the answer to this one is just square root 30. We can't really do anything with it at all. Let's look at part C. Part C is square root of 12. Well, looking at 12, is that a square number? No. But does it have a square factor? It does have a square factor. That's 4. So we can rewrite the square root of 12 as the square root of 4 times 3. So now we want to pull out this 4. The square root of 4 is 2. And then there's still a 3 left behind in the square root. So for part C, the square root of 12 is 2 square root 3. Let's do one more from number 4. Part D is the square root of 150. 150 is not a square number, but it does have a square factor. 150 is 25 times 6, because if you think about it, if you had $1.50, that would be 6 quarters. And 25 is a square number. What is the square root of 25? That's 5. And then we still have a 6 hanging out here in our square root. So the square root of 150 is 5 square root 6. So that's all that the first problem that you have in set 3 is asking you to do. So this is just like problem number 12. You're given a number and you need to give it square root. Don't give me a decimal answer. You're going to either give me the actual square root if it's a square number, like if you have 49, the square root of 49 is 7. If you have a number that cannot be simplified in the square root, then you just leave it like that, like square root of 30, you can't do anything with. Square root of 7, well, that's just square root of 7, you can't do anything with it. If there is a square factor for the number that you're supposed to take the square root of, then you need to break it down into its factors, pull out the square, take its square root, and then leave behind what stays in the square root. So make sure that you simplify your answer, but do leave it in radical form. I don't want a decimal answer. Okay, so now let's look at number 5. Go to the new page. There it goes. Okay, so number 5 says, express the two numbers represented by each of the following expressions in simplest form. So let's look at part B. For part B, we're given negative 11 plus or minus 7. So what we need to calculate is negative 11 plus 7 and negative 11 minus 7. Negative 11 plus 7 is negative 4. Negative 11 minus 7 is negative 18. So those are our two answers, negative 4 and negative 18. Let's look at part C. For part C, we have 8 plus or minus 2 over 5. Well, that means we need to figure out 8 plus 2 over 5, and we need to figure out 8 minus 2 over 5. Well, 8 plus 2 is 10, and then that's over 5. 10 over 5 is 2. 8 minus 2 is 6, and then that's over 5, and we can't simplify that. So our two answers for part C are 2 and 6/5. Make sure you put a comma in between your answers so that your answer does not look like 2 and 6/5. So it doesn't look like the mixed number. These are two separate numbers. You need to separate them somehow so that I know that they're two separate answers. Okay, then let's jump down and look at part F. Part F is 4 plus or minus the square root of 8 over 2. Well, the first thing we need to do is simplify this square root, because square root of 8 is not simplified. 8 has a square factor. So this is going to be, actually I'm going to come over to the edge here and work on square root 8. Square root 8 has a square factor, which is 4. So we can rewrite square root 8 as the square root of 4 times 2. We can pull the 4 out. When we take the square root of 4, we get 2. And then there's still a 2 left behind inside the square root. So I'm going to rewrite this fraction as 4 plus or minus 2 square root 2 all over 2. Now I can divide by 2 because 2 is in my denominator. 4 divided by 2 is 2. And then plus or minus 2 root 2 divided by 2 is square root 2. So my two answers are going to be 2 plus square root 2 and 2 minus square root 2. Please do not punch this in your calculator to give me a decimal answer. This is what I want. I want it left in radical form. So that's the way that your answer needs to look. So this was number 5, which is just like number 13 that I assigned for homework. Okay, the next thing we're going to look at is problem number 6. Problem number 6 gives you an equation, x minus 3 squared equals 36. For part A, it says solve the equation by writing it in standard form and using the factoring method. So for part A, they want you to solve this just like lesson 4 did. So in order to put this into standard form, the first thing we have to do is multiply out this square. Remember, anytime you're squaring a binomial, you write the square of the first term, and then you write the double of the product of the first and second terms. So 2 times x times negative 3 is negative 6x. And then you write the square of the last term, so that's 9. and that's going to equal 36. To write it in standard form, I need to have a 0 on the right side, so I need to subtract 36 from both sides. When I do that, what I end up with is x squared, sorry, that should be an x squared minus 6x minus 27, and that's going to equal 0. Now I need to factor this. Okay, so what are my factors of 27? My factors of 27 are 1 and 27, or 3 and 9. Those are all the factors I've got. Now, since this is a minus sign, that means that I need to subtract the two factors, and the number I'm trying to get when I subtract them is a 6. So the difference between 27 and 1 is 26, but the difference between 3 and 9 is 6. So this is the pair I want. So we know we're going to have an x and an x in our parentheses. And then we know our factors here are 3 and 9. Since this is a negative number here, we know one of them has to be positive and the other has to be negative. Since our middle term is negative, that means our bigger one is negative. So it's going to be a negative with the 9 and a positive with the 3. And that's going to equal 0. Then we use the zero product property to set each factor equal to 0, because if you multiply two numbers together to get 0, then at least one of those numbers has to be 0. So we're going to set x plus 3 equal to 0, and we're going to set x minus 9 equal to 0. Subtract 3 from both sides, we get x equals negative 3. Add 9 to both sides, we get x equals 9. So x can equal negative 3 or x can equal 9. Okay, for part B, it says to solve the equation by the square root method. So let's go back to our original equation. We have x minus 3 squared equals 36. To solve it by the square root method, we just take the square root. So I'm going to write that down. We're square rooting both sides. When we take the square root of a square, we have just what was inside of it. So that's x minus 3. And then the square root of 36 is going to be plus or minus 6. Don't forget your plus or minus, because we don't know whether whether this square we're taking the square root of was originally positive or negative. Okay, now we need to get the x by itself. We're subtracting 3 here, so to undo that, we need to add 3. So when we add 3 to both sides, we get x equals 3 plus or minus 6. So we need to figure out what is 3 plus 6 and what is 3 minus 6. Well, 3 plus 6 is 9. 3 minus 6 is negative 3. So x is going to equal 9 or negative 3. And what did we get before? We got 9 and we got negative 3. So both of these methods worked and gave us the same answer. For part C, it says, which method for solving the equation is easier? Well, I think this method was much easier. The square root method worked much better for this. It was very easy, where we had to go through a lot more work to do it the other way around. Okay, so that was number 6. It is just like number 14 that I assigned for homework. Remember, part A, you're going to rewrite the equation in standard form, which means you're going to have to multiply it out first, then put it in standard form, then factor it, then set each factor to 0 using the zero product property, and then solve each equation for x. With the square root rule, we're going to take the square root of both sides. Remember, the right side we're going to say is plus or minus, and then we just solve for x. Much simpler, much faster. Okay, so we don't really have time probably to finish the next problem, but we'll at least start it. Number 7, we have x plus 4 squared equals 15. And it says to solve it by the square root method. Well, the square root method means we just take the square root of both sides. The square root of x plus 4 squared is x plus 4. The square root of 15 is just the square root of 15, but we have to say plus or minus. Okay, now we subtract 4 from both sides to get x equals negative 4 plus or minus the square root of 15. And then for part B, it says write it in standard form and try to solve it by the factoring method. So we'll do that on the part 2 video.